Hey everyone, today I'm going to be going over the legal problem, subtree of another tree. So first, let's read the question. Given the roots of two boundary trees, root and subroot, return true if there's a subtree of root within with the same structure and node values of subroot, and false otherwise. So a subtree of a boundary tree is a tree that consists of a node in our tree and all of the node's descendants. And the tree itself could be considered a subtree of itself. So let's take a look at some examples. So in example 1, we have our two trees, and we want to see if the tree, the second tree, the one whose root is subroot, exists as a subtree of the first tree. And in this case, it does, right? Because 412 matches with 412. And in the second example, again, we have our two trees, but this time we will return false because even though we have a 412 here and a 412 here, because this subroot is missing the 0, it's not considered a subtree. So let me go over how I would solve this problem. So for this problem, what I would do is I would traverse the first tree. This is one where this is one where the root is called root. And every time we go over a node, we check if that node's value is the same as the node's value. So it's the same as the subroot value. And every time we every time we go over a node, we check if that node's value is the same value as subroot's value. And so there's two possibilities, right? Either they are or they aren't. So if the values match, then what we want to do is we want to basically compare the like the subtree and root. We want to compare the subtree of the first tree starting from that particular node, and we want to like basically see if it matches with the same with the second tree. We want to compare the two sub. Right, so if the two subtrees match, then we just return true and basically end the entire finish the function. And if they don't match, then we just keep traversing. So if the subtrees match, return true. Otherwise, we keep traversing. And now, so that's the case if they match, right? If they don't match, so if the two nodes values don't match, then we just keep traversing. And so if we basically finish traversing the entire tree, and we don't have a match, then we return false. So this is the general idea for how to like how to basically do the first part of the problem. The second part is this part, like how do you compare the two subtrees? And that's what I'll explain down here. So let me just write. So comparing the two subtrees. So first, you want to make sure that the node values match up. But so if we ever reach a point where they like is it like the nodes in the same position, but they have a different they have different values, then we know that like that cannot be the same subtree, right? So if the first thing we want to do is we want to make sure all the node values match up. The second thing we want to do is make sure that neither tree is missing nodes. And so there should be S here. So if you look back at this one, you see how this subtree has 4120, but this tree only has 412, and as a result, we return false, right? So if either subtree is missing nodes that the other one has, then we will have to return false. And we do this recursively for both the left and right child of each node. Other subtrees. So let me go back to the code. So in my case, I'm gonna in order to traverse the tree, I'm gonna use BFS. So and I'm gonna do this iteratively. I'm sorry, this should be it. So BFS, just as a quick recap, it traverses a tree level by level. And in my case, I'll go from like left to right. Again, it doesn't really matter what kind of tree traversal you use. Actually, like so this BFS and this DFS, it doesn't really matter which one you like between them you use. I just like BFS better, so I'm gonna use that. If you use DFS, it's like a very similar process. So basically what I'm doing is like so at each step, so what I'm gonna do is like yeah, at each step I'm gonna be popping the first node in this queue, and I'm gonna basically compare that node with the one in subroot. And this match, this will be a helpful function that basically compares the two subtrees. And I'll create this match function in a bit. So here what I'm doing is this, right? So if this result is true, then basically we just return true, and we just basically like sub this function, right? But if it's false, then we keep traversing the tree. So that's why we don't just blindly return results, because if result is false, and maybe like somewhere later down, there's like another case where that like in root or in the first tree that actually does match with subroot, then we will miss that, right? So the only time we return true is if result is true. And if result is false, we just keep going, we just keep traversing the tree. And again, so here I'm just adding or appending the left and right nodes of the current node that we just popped into this queue. And finally, if we've traversed through the entire tree, and if we traverse through the entire tree and we don't return true, then we return false. So that was the first function. Let me create a match function. So in this case, right? So let me go back here. So let me go over this part. So again, right, so we want to make sure the node values match up, and we also want to make sure that neither subtree is missing nodes. But what happens when both subtrees are missing nodes? So for example, like let's say that let's say we have something like this, right? This is our root, and this is our subroot, which is the same thing. And you know, like at some point we're gonna basically like we're basically gonna like traverse like the left child and the right child of like the leaf nodes. In that case, both of them like both root and subroot would be null, right? In that case. And so in that case, it would actually we will return true. So if not root 1 and not root 2, return true. So basically what I'm saying is that if both root 1 and root 2, like this we are at like a null point, right? Basically like we've finished traversing through like a leaf node and now we're at null, then we return true. And sorry, this is not. So in this case, so for missing, what this means is that either there's a node in root 1, but that node is missing in root 2, or the vice versa. There's a node in root 2, but it's missing in root 1. In this case, we will return false. And this part is what I mentioned in line 2 here. Check it and make sure that neither subtree is missing nodes. And it's not. And this part is the first criteria, right? We want to make sure that the nodes match up. If the nodes if the node values are different, then we return false, right? Because we know for sure that they cannot be the same like subtrees. And finally, we just recursively check the left and right subtrees. So, oh sorry, this weird. And let me just copy this and change it to right. This should be right, and this also be right. So basically what I'm doing here is like I'm recursively checking the left and sub like subtrees of the current node with the left and right subtrials of the current node. And so in this case, right, like we're recursively just checking to make sure that an entire subtree matches. And so yeah, so this is a code, and let me run this. Let me just do a quick test to make sure I didn't accidentally mess up anything. Okay, looks good. Let me submit this. Yep, and you can see this is a valid solution. And the time complexity of this will be O of m times n, where m is the size of the first tree and n is the size of the second tree. Thank you all for watching. I hope you learned a lot.